In this video, we're going to be learning how to solve systems of equations by graphing, and we'll just do a few examples. The first system that we're going to do is the one shown here, y equals 2x plus 5 and y equals 7x minus 10. And the steps we're going to use are to graph both equations on the same coordinate plane and then estimate the coordinates of the place where the two lines intersect. So y equals 2x plus 5. The y-intercept is 5, so we'll draw a point there. When x is equal to 2, y is equal to 9, so that point's right here. And then we can draw a line, and that will be our graph of the first equation. Make sure that it goes through those points, and looks like we're good. Now let's graph the second one. This is y equals 7x minus 10. The x-intercept, or the y-intercept rather, is negative 10, so that would be down here at the bottom. And the slope is 7, so we can go over 1, up 7, and that would be a point there. And let's do one more, over 1, up 7, to be right there. Okay. And then we can graph those, graph this one. And we'll start the line there, and there we go. And we'll notice that the point of intersection is right over here, and if we were to estimate the coordinates, it perhaps is not quite exact, but it looks like it's about 3 would be the x-coordinate, and the y-coordinate would be about 11. And it turns out that if you check that answer, it will be exactly 3, 11. Now here's the second one. In this one, the equations are in standard form, so the method of graphing is going to be a little bit different. So let's do this one. So for the first equation, we'll make a table. And that'll be the one for this. There's x and y. And let's see, if we make x 0, then y is going to be negative 2. And if we make y 0, we have 4x equals 12, so x equals 3. Those are our intercepts. So we'll plot the point 0, negative 2, and the point 3, 0. And that will give us our line. There we go. And we'll just extend the line in case the point of intersection is someplace down here. And now we'll do the second equation, x plus 2y equals 4. Once again, we'll find the y-intercept and the x-intercept. If we make x 0, we have 2y equals 4, so y equals 2. And if we make y 0, then we have x equals 4, so that was easy. And now we'll plot the points 0, negative 2, it's right there. Sorry, 0, 2 rather, that would be right there. And the point 4, 0, so 4, 0 would be right there. And let's draw that line. And now we'll notice that the point of intersection is not quite on a lattice point. So it looks like the coordinates of that may be fractions. And if I were to estimate this, it looks like the x-coordinate is about 3.5, so we'll say 3.5. And that the y-coordinate looks like it's about 0.25. Looks like it's about 1/4. So if we were solving by graphing, we would estimate our solution this way, and that would be good enough. If we were to do this out analytically, in other words, use algebra to solve it, we would find that the exact solution would be 24/7 and 2/7. And for decimals, this would be approximately 3.43, 0.29. And we can see that our estimate is fairly close. So this, when you're solving by graphing, this estimate is just fine. Now let's take a look at this system. 4x minus 6y equals 12 and 2x minus 3y equals 9. So 4x minus 6y equals 12 we graphed in the previous example, so I just have it on the graph here. Now let's graph 2x minus 3y equals 9. So we'll make our table, and we'll select x and y coordinates. We'll make x0 and y0. If we make x0, we find the y-intercept. So if x is 0, we have negative 3y equals 9. So y is negative 3. And if y is 0, that means 2x equals 9, or x equals 9 halves. So let's graph those 2 points. So 9 halves is about 4.5, so there's 4.5 would be right there. And 0, negative 3 would be right about there. And let's draw the graph of this line. And we'll just extend it. And it looks like these two lines are parallel. And in fact, they are parallel. And if the lines are parallel, which also means they have the same slope, then this system has no solution. Okay? And later on we'll learn that this is called an inconsistent system. Let's look at one more. We'll take 4x minus 6y equals 12 and 2x minus 3y equals 6. We will quickly plot 4x minus 6y equals 12, which we know we can do this way. And now we will plot 2x minus 3y equals 6. Let's find the intercepts. So x and y, so we'll make x0 and y0. So if x is 0, we have negative 3y equals 6, so y equals 2, no, negative 2. And if y is 0, we have the x-intercept is 3. So we'll plot the point, well, 3, 0 happens to be right there. 0, negative 2 happens to be right there. So these are the same line. These are the same line. So this means that this system has an infinite number of solutions. And we can write the solution to this system simply by writing one of these equations. So we can say that the solution is 2x minus 3y equals 6. So that's another way of writing the solution. In this case, the solution is said to be to have an infinite number of solutions. It is a consistent system, and it is also a dependent system because these lines are the same. So if we go back to our original example, just to review, the way we solve a system of equations is we graph each of the equations together on the same coordinate plane and estimate the coordinates of the point of intersection, and that will give us our solution. When you're using a system where the answer is not integers, the coordinates are not integers, then you just have to estimate, and estimating to the nearest half is just fine. And this is a great estimate of our solution.